Okay, exponentials is not a polynomial. Okay, this is where the expression, where the variable is the exponent. That's what makes this different from everything we've already done. Okay, the expression where the variable is the exponent. And so we'll do just a few examples here. 2 to the x, not x squared, 2 to the x. The variable is in the exponent slot. Or 1/2 to the negative x. The bases are the number, the variable is the exponent. And my exponent, that's a 2x plus 1, can be an expression. But my exponent's kind of variable looking, or kind of polynomial. So they're switching places, which means we have to be careful about what kind of properties we're going to use. So we're going to write down our exponent rules again, except we're going to switch the places of where the variable usually is. So we're going to start with the product. Okay. And we did exponent rules. We did them in Unit 5, except that time the variable was usually the base. This time we're going to change this and we're going to say base to the x and base to the y. The variable is now the exponent. So what do you do to exponents when you multiply the same base? You add them. Base x plus y. We're writing them down in this format because maybe we haven't written them with the variable and the exponent before. Same properties, but they look and feel different. Okay. So product of same base, you add the exponents. Okay, so then we're going to open it up and we're going to try the examples there. Okay. So when you're ready, open up that flap. And let's try it. Okay, so 3 to the x times 3 squared. Add the exponents. That's it. Yeah. Yeah, that's a 2. They don't always have to be variables. They're going to be mixed, numbers and variables. And so in this particular case, the base is 3. And the exponents are x and 2. Okay? Let's try the next one. Notice how it says simplify, but I gave you a format, base to the x. So we just want to be able to find the base and then the new exponent. So the base is 2, and we add the exponents. Then we leave it. Base 2, exponent 4x minus 2. It's okay to leave this expression as is. All we're trying to do, look, we went from a product to a single expression. Do I have b to the x? Yeah, one base, one exponent. Okay. So we're going to do the quotient, and then we'll open up the other side. Okay. B to the x over b to the y. B x minus y. Notice I start putting parentheses around my exponent because there's multiple terms there, and I'm going to make sure that I've grouped them so that I know they both apply to the one base. Okay, quotient of same base, subtract exponents. Okay. Open the flap. Try the first two examples. Okay. 5x minus 3 Okay, same base subtract exponents. I didn't put an equals there because there's no equals here. This isn't an equation. I'm just rewriting the expression using my properties. I like the grouping symbols to make sure I know that exponent applies to the base, both parts of the exponent. All right, bottom left, power. Okay. Base to the x, y. Notice that I put that whole expression in parentheses, meaning that all of this is raised to the y power. Well, means you right? Power to a power means you multiply the powers. Power to a power multiply exponents. First, we're looking at just the properties. The second thing we're going to do is actually use them in the equations. Could I leave grouping symbols here? Sure. Could I add brackets to make sure that the x times y is the exponent for the whole expression for the base? Yes. Okay. Flip it open. Try the first two examples. Right, the first two examples are straightforward. Then it starts getting a little bit trickier. could I write it? Okay, so if I open it, power to a power 2 x times x plus 1, and simplify x squared plus x. Okay, that's it. Now, I know you see that 2 cubed, you're like, oh, 8. It could be an 8, but let's use the power to a power property. And so the first thing I get is multiply 3 times this. As we start applying this to the different problems, we'll see why we might want to be able to do this. 6x plus 3. Could I also just call this 8? Sure. That wasn't really using the property, but that would be an equivalent expression. This is using the power to a power property. Notice the distribution, right? That's why you want to make sure you're using those grouping symbols. Other answer. Okay. Those were pretty straightforward examples. The next 2 columns are going to be a little bit trickier, kind of mixing some of the properties. Okay, so we're going to write down our negative rule, and we're going to see what we can do. B to the negative x. Now, that's negative, okay? So, sometimes, we're going to write this 2 ways. You get, all right, negative exponent means reciprocal. We're going to do it a different way. So let's say we get base over, I need another letter. No, let's go P. I know. Base, B is nice because it stands for base. I was trying to think of another word. I couldn't. Okay, but if I have a fraction, right, with a negative exponent, it's better to avoid the complex fraction and go straight to the reciprocal. If there is no fraction to begin with, doing 1 over works fine. But if you have the fraction base to start with, it's better to just flip so that you can avoid the complex fraction 1 over b divided by p, right? Skip the complex fraction part, go straight to this part. Okay, so combine is simplify. 2, 1, common base. Right? Usually that's going to be b to the exponent, which is some expression. Oh. That's what we're looking for. Can you write this with a base and an exponent? Some polynomial expression. Okay, and rewriting, simplify 2, 1 base, and x only. So a, b, x, where x is it. Not an expression, just x. You're going to have to use the properties forwards and backwards. So if I'm looking at these arrows, these are actually Was that biconditional arrows? The properties go both ways. You can combine or separate. Okay, we're going to go one row at a time. We're going to start with the top two boxes. So when you're ready, open up that first flap on the top right, and let's see if we can do those questions. No, I left one of them off, so I'll write it in for you. You are trying to write this a times b to the x. Okay. Well, which means I need to get the exponent to be just an x. So separate. Go backwards in that property. If you add the exponents, that means that you multiply the same base. Right? That's the property backwards. You should always practice your properties both directions. Okay, so that 2 to the first is just 2. Okay, so I'm going to put my grouping symbols in here. Bottom left property, that's the power to a power property. Can you rewrite 2 to the 2x in a different way? Right, I'm separating my exponent into powers. I'm going to lightly draw in some grouping symbols. Can you do that first? Just a power to a power. Let me zoom that in so we can actually see it. No, it wouldn't. What's 2 times x? Power to power means multiply.
Oh, that's a 2? That looked like
yeah, I know it did. I know. They look the same. That's why I zoomed in. That's a 2x. Okay, do we see the progression? Can you do the red brackets first and get 4? Yeah. 4 to the first, or just 4, x times 2. Is that a times b to the x? Yeah. Instead of going forwards with my properties and combining, I split it back up. So really, if I wanted in this format, I would say 2 times 4 to the x. And I think I'm going to put grouping symbols here around the 4. Notice, guys, that's not 8 to the x. It's not 8 to the x. I like to leave that times here so I can see that they're separated. I'm going to leave the times so you can see that's 2 times 4 to the x. Okay, see if you can do this one. Then we'll do the right column. Right, you've got 2 more here. There's your example. There's your format, a times b to the x. See if you can go backwards in your property. Separate it down to multiple bases and simplify. Separate the top. Right? Try to get the exponent, that's the x, apart from the numbers. You want b to the x all by itself. So try to separate the other powers. Okay, so let's see where we made it. Okay, I am trying to get this part all by itself, right? That's the part I want all by itself. So I'm going to try to separate the things around it. 5 to the x times 5 to the negative 2. Okay, that's the first thing I did. You can add negatives, that's fine. You have to stay focused on the piece that you want to stay. This is the piece that I want to stay, and so I'm going to use my exponent rules on the other stuff. Okay, means I'd like to try to combine these. So let's leave 5 to the x, and I suppose my exponent rules tells me that's 5 cubed. That's unit 5, guys. That's just like, actually that's algebra 1. Just move that to the bottom and add the exponents. Now 5 cubed is really 125. I'm looking for this format, so I would like a number times 5 to the x. A number times 5 to the x. And you might be thinking there's no reason to be able to use your properties like this, but it depends upon the context of the problem, what might be needed. Really understanding the property means that you could work forwards or backwards with that one property. And you never really know which direction you're going to need until you get to the problem and you read it. Okay, so here we go. I need the x and this. Now, could you call that 9? Sure, it doesn't matter, guys. I'm not going to be picky on that. You want to call it 9 instead of 3 squared? It's fine. Okay. So, seems like a reasonable thing to do. It does make my problem a little simpler looking. Okay. I need the base and the x separate from the other parts. So I need to get my exponents apart. 9, 2 times 9x. Ooh, I got it. I got 9 to the x all by itself. This is what we're looking for. Oh, well, 9 squared is 81. 81 times 9 to the x. However you're going to write that expression, do not multiply 81 and 9. Because you can't PEMDAS, E, you'd have to do the exponent simplifying before you try multiplying. Okay, I'm going to write up 3 new problems. You have the format over to the right. Okay? One base and an exponent. Base and an exponent. So I gave you the kind of expression you're looking for. mx plus b. Okay? A, b to the x. That's how you're trying to rewrite it. So here you go. 81 to the x times 1/3 to the x. Two to the 2x over 4 to the negative x plus 1. Okay. Ooh, I gave you different bases. Maybe you should try to rewrite the bases with the same base. Right? That's one base. Think of your factor trees. What kind of bases do these things share in common? If you need to combine to a single base, you're going to have to rewrite the bases first. Okay, you fill in what kind of exponents could get you there. right? I notice 81 and 1/3, they're all kind of factors of 3. So what kind of exponents are you going to use to get from that first line to the second line? I can't use any of my properties until the bases are the same. Okay, what if we put 4x, right, because 3 to the 4th is 81, and the x is still there, and here, just negative x. The more properties you have to use, the less steps you might show, but none of your properties work unless the bases are the same. And so when you don't have the same bases, you're going to have to do that first. Now that I've got the common 3, now I can add up my exponents. So 3, 4x plus negative x. So I would accept this as an answer. That's great. Could you write it such that x was all by itself in the exponent spot? Uh-huh. Not 9. 27. That's okay. That's a common mistake. Right? You're like, no, add exponents. Wait, no, multiply. Yes, power. 3 cubed. Okay. Try the second one there. Only because what you're really doing is you're undistributing the x. Okay, the only reason you can do 81 divided by 3 is because the exponents are the same. And so, but it doesn't work if the exponents are the same. That's fine. If you see that property, show it. It's totally fine. But it's not very common to have the exact same exponent. Yeah. But yes, as long as you know what property you're using, use it. Cool. Okay. So 2 to the 2x. Let's do this. Can you get a 2? I would always choose the smaller base if I had a choice. So I'm choosing 2. I left a little spot. How are you going to make that bottom base a 2?
So you can do that.
but we're not looking to get any numbers in front. We're looking just to get the base, which means you want to leave it in that exponent format. That would be negative 2x plus 2. Negative 2. Yeah? Yeah. Either way, yes. I just chose the smaller base. Only because you got lucky that that square was there. Right? It wouldn't necessarily be. Right? Yes. Okay, Zanus, that's actually this one. See this format? They're actually going to be the same problem, so that's fine. So look at the format. I want it to stay with just the base, no numbers in front, and everything in the exponent. Here, I wanted just the x. There are reasons to do either direction depending upon what the problem's asking for. Okay, notice I want just the exponent, nothing in front. And so if we combine, this is a 2, so I'm going to get 2x minus, a little bit short on space, I can do this, negative 2x plus 2. I subtracted my exponents. And so here I get 2, 4x plus 2. Notice that I wanted just a base and everything else in the exponent slot. Okay. Now, some of you may have written that with a base 4, and that's okay. Your answer would have looked like this. 4, 2x plus 1. I don't care which way you wrote it. It's both. It's right. Both of them are correct. But notice that I have just a base and everything else in the exponent. That's all I wanted. Okay, this is the same problem. Okay. It's the same starting point, but I'm asking for a different format. I'm asking for b to the x, and then everything else separated.
I have 2 questions.
Yep.
One, why did you pick the top one to go first, like the 2x? Couldn't you have started, like...
I could have started with saying 4 to the x and
Okay.
then been faster to get the same base.
Okay.
You're not always going to have that opportunity, so I chose the smaller of the 2 options to write.
Oh, okay. And then...
No particular reason.
Okay. And then also, should be 4x minus 2? Because it has...
Yes, it should be. Good catch. Good catch. Sometimes, yeah, so that one would be minus 1 and this one would be minus 2. Yeah. Okay. Okay, so I need this and this, this and this. I need the b to the x's combined. All right. I feel like I'm going to have a lot of steps here. I'm going to call this... Yeah, let's do that. Let's go 4 to the x, because that gets me down to b to the x. Let's call this 4 to the negative x times 4 to the first. I'm trying to separate out b to the x, and then everything else separate. So let's this. So I got to put these 2 things together. 4 to the x minus minus x, and I still have a 4 to the first here. So let's just call this 1/4 4 to the 2x. Oh, I'm almost there. Let's call that 4 squared. Let's call it 16. Times 16 to the x. No. Right? PEMDAS. Exponent rules go before any multiplication. Yes?
Why would it be minus one thing?
Because it's division, so we subtract. It just happens to be a negative.
Wait, can you just move that one to the top?
And call it 4 to the 2x? Yes.
Well, because it's 1 over 4.
I was just showing the subtraction. Okay.
That's 4 on the bottom. There's 1 up.
So we're going to do maybe two examples right now, I think. 1, 2. I had 4 of them, but I think we'll just do... Oh. Okay, I got it. Ready? Why did we practice this? I will show you why. Okay? I'm going to close it. That's your... Sorry. We're going to try to do 3 examples. Can I close it? Okay. So I'm going to turn my page because that's going to take up my whole page. Part 1 was properties. Part 2 is solving. So we're going to start with a statement. If b to the x equals b to the y. Ooh, if-then statement. Then, yeah. Period. If, then. Oh, that's a nice highlighter. Okay. What we did is we practiced rewriting these expressions in different ways, and now what I'm doing is I'm setting 2 expressions equal to each other. Right? I have 3 to the x on the left, and I have 3 to the 2x plus 1 on the right. I'll put little grouping symbols around that exponent. Now, corresponding, what is that? CP, I can't say it. Corresponding parts of corresponding parallelograms. Okay, corresponding parts of these expressions are equal. Look, the 3's are the same, so that means that the exponent should be the same also. So x is negative 1. Okay, these are simple exponential equations. Some of these you'll be able to do in your head. If the bases are the same, then so are the exponents. Corresponding parts of this equation are equal. But be careful. This is written exactly b to the x and b to the y. There are no extra coefficients. There are no extra parts anywhere. Just a base, just an exponent. Okay? Now, your exponent could be any expression. Let me finish and then I'll take your question. Which implies, okay, if the bases are the same, then the exponents are equal. And then I turn that into a very simple linear equation. Solve. But what's new? Corresponding parts of this exponential equation are equal, but in a very specific, limited format. There's nothing extra here. Okay, so pretty quickly I can say x equals negative 1. 3 to the negative 1 equals, we're not really checking this, guys. I'm not doing powers. That's it. Check, done. Extraneous doesn't really happen. It might, but not yet. Okay? All right, let's do another one. Question? Okay. Let's see if I can up the difficulty just slightly. Just a little bit. Okay. Oh, okay. Well, I see a 4, a 2, and a 1/8. This is only going to work if we can rewrite each side of the equation in the b to the x format with the same base. That's why we practiced our properties. Now, I see right here, I see 2 to the x and 1/8 to the x. I would pick the smaller of the available bases, and I would try to get 2 on both sides. So can you get this? Can you get it like this so that the bases are the same? You've got properties. See what you can do to get there. That's why we practiced rewriting each expression. Now you need to rewrite to get a 2 on both sides. Okay, think of your property choices. Rewrite it. Notice that I'm asking you to use your properties. PEMDAS. Do not multiply that 4 and the 2. Exponent rules. Exponent rules come before multiplication. If you want, that's a 4 to the first. But it's not 4 times 2. Exponents go first. Means you have to use exponent rules to rewrite this. Okay, so that's what my left side looks like. Don't write too small. Make sure you see the distinction between bases and exponents. Implies. Okay, we'll stop here. Your homework is worksheet 1 and 2, which is actually just a front and a back. Okay, worksheet 1 is the front, worksheet 2 is the back. You can go with evens and move on from there as needed.